All right, so it should go without saying that we use technology in pretty much everything, but it goes a little farther than some of you might even expect. And today we're going to look at just how far-reaching computing technology has become. And just as a note, I took this class during the spring of 2015, and the ways that technology are used has remained pretty much the same, but the technology itself has improved a little bit. I think it's safe to say it's only really gotten better in the last 6 years. So, beginning with our reliance on technology and a brief history of what computers were and what they became. So computers as we know them started around the 1940s, and these used vacuum tubes, which are just clear tubes that are used to conduct electricity from one point to another. One form of these that you may be familiar with, one that held on longer than most, is the cathode ray tube. Those were seen in older TVs. If you've ever seen a box TV or monitor, something like that, those used cathode ray tubes, and that is a form of vacuum tube. After a while, those were replaced with transistors in computers, which is essentially just a tiny binary switch. It has two states, on, off, and a bunch of these grouped together into a circuit can create information. Say you have just one transistor, that only has two possible outputs, 0 or 1. But if you have, say, 16 of those, all connected to each other, each one of those doubles the number of possible outputs. So now you've got over 65,000 things that set of transistors can represent. And computers nowadays, the microprocessors that serve as the central processing unit for them and handle all of the basic functions of the computer, have billions of these on something about the size of a postage stamp. So as you can imagine, they're tiny. In fact, I did the math and did some research yesterday for my own curiosity. They're measured in atoms, silicon atoms to be specific. And a typical transistor is about 70 atoms in width, which is about 0.15 nanometers. So there's you some perspective on just how small these things have gotten. And it's because of that process of miniaturization that we've been able to get to personal computers. Those rose to prominence in the 70s and 80s with computers like the Apple Macintosh and the Commodore 64. Very old machines, very limited in what they can do, and very slow by today's standards. But those were among the first personal computers. Moving on to the Internet of Things, you may have heard this term floated around here and there, and all that refers to is common everyday devices that have been enhanced with computing tech. Generally, a processor has been installed on the device itself, along with some other hardware and software, so it can communicate over the internet. Some examples you see on the right, you have smart thermostats that you can control through your phone, smart cars that can report traffic accidents and monitor your vehicle's condition. You've also got things like a smart fridge I've heard of. I've never actually seen one in person that can monitor what you have in your fridge and tell you, hey, you should pick this up. You're running out of, for example, mayonnaise. On a bizarre note, there have also been smart toilets. These can have medical applications where they examine waste and try to detect bacteria cultures that can indicate disease. And as you can imagine, these embedded computers have very limited functions. They're very small, but they're not meant to be full-blown computers necessarily. They have a job and they do it. Moving on to artificial intelligence, something that has gained a lot of attention in the last several years. This is used in all kinds of things. It is generally just using programming logic and information from prior experiences to make decisions on the fly. It's commonly used in video games, but it's also used in managing data, and anything that might require some kind of complex decision making on the part of the computer. Speech recognition is another popular example where a program will recognize your voice, learn your accent over time, and eventually you don't have to quite sound so robotic while you're talking to give it commands. Virtual reality, again, something that has become really popular the last several years, where a real or fictional environment is simulated using a device that gives the user a 3D space to operate and manipulate. Again, very common use in the video game industry. Can also be used for training simulations, for on-site job training. And then you also have augmented reality, which is a form of that, wherein you take a real-world image, like the one you see on the right, and it overlays digital information. A very well-known example of augmented reality was a bit of a fad several years ago. I don't know if any of you jumped on the Pokemon Go craze. Well, it was hot, but that is an example of augmented reality, where characters are drawn onto the screen using your phone's camera. Any questions before we move on to the next section?
Hey, can you go back real quick?
Where to?
Yeah, that slide right
there. Anything you wanted to ask about this, or?
No, I was just trying to write the last part of the definition down for AR.
Oh, okay. And just let me know when you're ready.
Okay.
Okay, so moving on to more personal uses for technology, getting a little more specific. It should really go without saying that it is absolutely everywhere. But just how everywhere? So we've mentioned that artificial intelligence is used in games and in data management and speech recognition, but it can also be used in home security systems to, say, recognize faces. Say it knows you, it knows your face, and it doesn't sound the alarm when you show up. I'm not sure if this is a feature of home security systems, but this is more of a hypothetical example. Can also be used in navigation apps that will monitor road conditions and traffic, among other things, to plot the best route for you. And then you have things like natural language processing, which will take the words that you say, digitize them, and produce spoken words for, say, dictation software, where you just say the word and it writes it down. Or it can be used to process commands for things like Alexa or Siri, or Google Assistant if you use an Android phone like I do. Machinery has been used to enhance productivity. We have the use of robotics is very common in industry, and as you can see here, even in agriculture. This is helpful when a task is too tedious or precise or even dangerous. Like, say, this example here, those strawberries are a little out of reach, so it doesn't make sense to have someone step over everything and damage other plants when we can just have a robotic crane reach out and pick it for us. In addition, you have robotic arms and cranes that can be used to assist surgeons in hospitals. It might hold and manipulate a light, or it might even be there to perform specific actions while conducting surgery, like making incisions. As far as those with disabilities, technology has been a critical element of leveling the playing field for folks such as myself. I, for one, use a screen magnifier. You may see it being used from time to time during these lectures. If that makes you dizzy or motion sickness while I'm using it, I apologize. Just let me know. But it goes well beyond that to screen readers like JAWS and Window Eyes, alt text. If you've ever hovered your mouse over an image on a website and a little text bubble pops up, that's alt text. And what that is there to do is, number one, give any user a quick description of the image if they need it, but it also gives screen readers something to speak. So a blind user knows, hey, here's an image of hot air balloons. And you've also got assistive hardware. I have personally seen and at one time used a one-handed keyboard intended for people with cerebral palsy or for amputees who just don't have one of their hands to use. There's a place in Talladega called E.H. Gentry, if you haven't heard of it, that one of their buildings is a technology center that is loaded with all kinds of technology like this. There's more here than we could cover in this lecture. And there are things to help just about every kind of disability, physical, mental, learning, etc. And as we have been attempting to move toward greener options, more energy conservative, resource conservative. I apologize, I'm stumbling. We have the same thing applying for technology. We have the EPA's Energy Star program, which, if you want to know more about that, you can look it up on the EPA's website. There's also recycling programs for technology. I don't know if they're still around, but a long time ago, I saw ads for one called G-Cycle that would even pay you for bringing in your what they call electronic waste, old computers, phones, electronic parts, and so on and so forth. It's like the old turning in can tabs, or the old days of glass bottles, taking them to be recycled, and they give you a little bit of money for it. Just a little incentive so that you don't just throw your old stuff in the trash and it goes into a dump. paperless communication, reliance on email instead of sending out letters via snail mail is becoming increasingly prevalent. Number one, it's faster. Someone sends out an email and you've got it in seconds. Someone sends out a letter and you get it in 3 days. Number one, it's more practical. And number two, it doesn't burn up a whole bunch of paper and we cut down fewer trees. And lastly, we have telecommuting, which is exactly what we're doing now. We are attending a class, or I am going to work in an online setting from my home, using the internet, email, or telephone. This sort of remote work, telecommuting rather, has been a great help to people in light of the COVID-19 pandemic. All right, moving on from personal to professional. Does anybody have any questions? Do I need to go back before we take on this last section? All right. So the professional world is even more expansive than the personal world, as you can imagine. Every industry has its own technology. Every department within a particular industry is going to have its own needs, which would be satisfied with their own kind of hardware and software. And so we're going to go over this. There are quite a few slides on this one, so let's dive straight in. First off, in addition to, just about every career you could take relying on technology, there's a wealth of technology careers that you could pursue if you so choose. Not all of these require you to be an expert programmer. In fact, a lot of them don't require you to be an expert programmer at all. You do have, of course, your software and hardware engineers who put together new and improved machines. They design apps, or one common job for people to take interest in who take the CS major is game design. I personally, I started this whole pursuit of a computer science degree because I wanted to learn how to make video games. I grew up with them my whole life. They have been my main hobby since I was like 4 years old. So naturally, I wanted to make them my job. And in doing so, I discovered a whole world of things that I enjoy doing, like database systems. That's another area of interest. It's another entire career path someone could take, along with cybersecurity, networking, just going and building networks for businesses, wiring things up, and getting in. I've heard of people getting paid $500 to $1,000 for a day's work doing that. You've also got more people skills related tech jobs like consulting and sales, working in tech support. You've got technology services and repair, people like Matt's Computers, I believe it's called, down the road across from Walmart. That's an example of service and repair. You've also got web design, which if you hang around on YouTube long enough, you're probably going to see ads for things like Squarespace. And yeah, that's related to the field of web design. In the workplace, we have all kinds of collaborative and integrated software and hardware. For one, we've already mentioned telecommuting. There's also the use of things like cloud storage. If you've never used the cloud before or have never even heard of it before now, what that essentially is a data storage service where you can upload your files just to a server off somewhere else so that it's not taking up space on your computer. These services range from free to expensive, and generally speaking, the free programs are enough for the everyday user. I personally use several to make the most of free space and to keep things in separate places. It is very convenient, especially for businesses where people are working on things together and need to have a common ground for storing files. You may also see some companies adopt a BYOD, or bring your own device policy, which is exactly what it sounds like. You come into work with your own laptop or tablet or whatever is required of you, and you sign into their system when you start working, you sign out when you leave. These policies are not universal. You're not going to see them absolutely everywhere, but they are quite common. And an internship that I held here back in 2018 followed a BYOD policy. You can also have collaborative collaborative productivity software. Google Docs is a popular one where a bunch of people can be invited to one document and they all work on it at the same time. For software developers, GitHub is a lifesaver. It allows you to have this entire repository for a program with its source code, a built version of it, all this good stuff. And it merges updates as people bring them in, so things don't get messed up, wires don't get crossed. And it generally just makes making things so much faster. Education is obviously a big place for technology. Schools use social networking for events, collaborative assignments and projects, and also to teach things like online etiquette and legal issues. On that note, in 2018, some of you who graduated last year, you may have already seen the effects of this starting to roll in, depending on the school you went to. I'm not entirely sure, but in 2018, the state of Alabama passed an education initiative called the DLCS, or Digital Literacy and Computer Science. And what this does is it brings in technology education from kindergarten all the way through to the end of high school. So students will begin to learn at a very young age how to use computers, how to program, even how to keep their network and their information secure. It's a huge and ambitious program, and as a master's student, I'm actually working on being a part of this. In transportation, we've already mentioned the use of GPS and the artificial intelligence that goes with it, but it can also be used to track packages. I, for one, am a common user of Amazon, so this is exceedingly helpful to me. And then there are driverless cars. These are legal in some states. Some places have them for private and public transport. I've seen news articles of entire fleets of driverless buses. I wasn't sure if those are already in place or if they are just being worked on, but these are things that are being talked about at the very least. So Driverless cars are a growing thing. Expect to see them at some point in your lifetime, maybe even here in Alabama before too long. Who knows? In healthcare, we've mentioned the use of robots to assist doctors, but we also have doctors using their computers to monitor patients, keep track of your vital signs, have, say, your heart rate, blood pressure, and all this, all feeding to one computer. They can also use them to research medications, diagnoses, and other such things, because they can't be an encyclopedia of all this, of course. Even though they went to school for 8 years, did a 4-year residency before they could be a full-blown doctor. Excuse me. They still have to look things up. They still have to read up on things and make sure they're not about to prescribe you something completely off the wall. And in addition to this, we have mHealth, or mobile health, where a physician can access medical history from their device. So say they're going to prescribe you this one thing, but then it turns out you have a condition that would cause this medication to not perform as it should. It could cause some serious side effects. Well, they thankfully had your records on file. They could look at them and see and make that decision. Patients can monitor their own condition, keep track of their medications, make sure that they have taken their medicine at the right time, or say they're looking at their blood pressure on a device that they've been given, and they see that, hey, I'm taking blood pressure medication and it's still going up. I know now that I should contact my doctor. Just little quality of life conveniences all over the place that we see. On that note, there are medical monitoring devices. Someone might get a heart rate monitor surgically implanted or placed on their body that they have to maintain for a period of time. This happened to my dad for about a month or two after he had 2 heart attacks. So those work nicely. If they detect any sudden change, they'll contact your doctor and alert you. And finally, in the medical world, we have 3D printers, where physicians and medical researchers have discussed the idea of using them to print medical devices and other such things that will fit your exact anatomy. So say, no, we don't have to worry about pacemakers all being the exact same size. If someone is, say, a little smaller than the average person, it might call for a pacemaker that is ever so slightly smaller. Manufacturing relies, again, on robotics heavily. These machines can be used to monitor excuse me, I'm jumping ahead. We use computer-aided manufacturing to design models of new products, and we can do this through software, so we don't burn up valuable and limited resources, which is cost. We can also have machines manufacture these products in situations where it would be too tedious or dangerous or even too precise for a human user to design them. There are machines and parts that require precision measured in fractions of a millimeter. Machines are capable of handling that kind of precision. We're not. So without the use of robotics, that places an upper limit on just what we can make. Database systems can be used to monitor the inventory of parts and other such items that a manufacturing plant requires. And if, for example, they are running low, it can notify a manager or whoever is in charge of parts and let them know, hey, we need to order this, or potentially it could be set up to order them for everyone, not requiring any sort of intervention. And when we have complex machine setups, we can also have those machines talk to each other using M2M communication or machine to machine. They can monitor each other's conditions, let each other know when they're done performing a task, when they're ready to receive some material to do their part of a task, and generally just automate a whole process. And there's understandable concern that that takes away human jobs, but the question has to be asked here. If you have a bunch of systems watching each other, who then watches the watchers? And the answer is people. At some level, there has to be some kind of human intervention in technology, and that is where the job security is going to lie. Coming back to education, this time with higher education, you are very familiar at this point with the use of LMS, or learning management systems. These wrap up pretty much the entire function of a class into one piece of software. You can access your ebook through something like MindTap. You can access course material, assignments, complete exams, or you can even access other software that has been embedded into the LMS. Something like, for programmers, one embeddable piece of software that I'm quite fond of is Trinket. It allows for programming in Python and a few other languages, and it could just be dropped directly into any LMS or any website that allows embedding. I don't want to spend too much time on talking about higher education because you're all very familiar with this sort of thing by now. Canvas obviously is not the only LMS out there. Google has its own with Google Classroom. JSU used to use Blackboard, which was fine. Canvas is a definite improvement, in my opinion. And there's also Schoology and others. And finally, getting ready for a career in technology, and most of this applies outside of technology too. If you're going for any career at all, there are professional social networks like LinkedIn that let you search for jobs, or not let you search for jobs, that let you post your resume, your portfolio, your education background, and all this other good stuff that employers want to know, and they can search for you, and if they have a job that you fit, they can reach out. There's also other ones like Indeed, where employers can post jobs and you can go in and search for them and apply for them. For technology and possibly others, there are certification programs, and these allow you to build skills that can supplement, or in a few cases, even replace a college degree in whatever field the certification is in. And these give you a chance to build the skill and also demonstrate it. They often end with a project that you can keep for yourself that says, yes, I know how to do this thing. I know how to design a website. I know how to secure a network, et cetera, et cetera. These are not usually free, though. Just like any other education system, they're gonna have to pay for it. Some of them can also be quite expensive. I've seen some that range in hundreds of dollars for the course, or even thousands. And I personally have never taken those because of that. I can study things on my own. I don't need to pay $7,000 to take a class in one thing. However, for those interested in web design, there is a free option, and I highly recommend this one. It's called Free Code Camp. If you're interested, I can post a link to it. They have courses on HTML, CSS, JavaScript, all the things you need to know to begin building a website from scratch. And those offer certifications, which require you to complete a series of projects that you can then keep and add to your portfolio. And it also includes things like Python certifications, which can supplement web design, but Python itself also works very well outside of that as its own thing. So again, that's Free Code Camp if you're interested.